Hi everyone, I am Monsieur Mohammed, and this is my first video explaining the workflow of 4D and 5D simulation for construction phases. Before we start, and as you already noticed, I'd like to mention that this video will be in English, as nearly 80% of you preferred English in the latest survey, so English it is. I'll begin with an introduction to explain the reasons behind this workflow, how the idea originated, and the main challenges that led me to develop it. As many of you already know, BIM technology is crucial for construction projects and has a significant positive impact on the AEC industry. Nowadays, it's used globally across all project phases, from initiation and design to maintenance and facility management. In our case, we'll focus on design and construction phases. Design teams typically use BIM software like Revit because they recognize the benefits and the power of having a model with all necessary information, allowing for quick and efficient control and changes based on owners' requirements. However, construction teams are not always open to this technology. The real challenge lies in the construction phase and the site team. In theory, the design team provides a model with all the necessary information to the site team, who then use the model to create the project and coordinate on site using specialized software such as ACC, Build, Revisto, Navisworks, and Synchro, and others. But unfortunately, most of site teams are accustomed to paper and 4D planning tools like Primavera or even Excel for small projects, and they find BIM software too expensive. This was a significant issue in my case. I always tried to demonstrate the benefits of BIM software in construction for the construction team, but the site teams were not very interested. They preferred to spread money on equipment and materials for the site. For the site team, it was a case of on ne change pas une équipe qui gagne. We won't change a winning team. The main problem was getting the site team to use the model already created by the design team and to understand the value of BIM technology. So the solution has to be free. Use simple tools like Excel and paper plans and be easy and impressive to project managers. Now I initiate the workflow by crafting a concise mind map. This visual showcases the interconnections among teams as well as the various platforms and software involved. Let's deconstruct the workflow into three distinct teams. Design team. The design team is responsible for utilizing BIM software to develop the model and incorporate all essential design information. A critical aspect is assigning a unique ID and geometry to each element within the project. Site team. The site team plays a vital role in implementing the project according to the established plan. They are responsible for meticulous task management and supervision of all on-site activities. Additionally, they must use the quantities and cost associated with each element to facilitate procurement, ensuring accurate tracking of real cost and quantities used during the project's execution. Management team. The management team plays a crucial role in ensuring the project runs smoothly and stays on track. They monitor overall performance, verify that tasks are being completed as planned, and analyze the design against actual on-site quantities and costs. This focus helps them provide effective oversight and make timely decisions. Let's start with the design team. The design team is responsible for creating the project model and adding the necessary information to every element within the geometry. As you can see, we have created filters in this view for each phase, which will later be used for tracking the elements of our project. Each element is assigned phase information. In this example, we've added a text parameter that will be filled manually. And as you can see, each element includes this information. The columns, for example, as we can see, every column has the information of the phase, as we can see here in the information part. Let's open, for example, the foundation plan. Here we are, we have the foundation plan with colors of every phase, and we have the tags of all elements. As we can see, we have also the schedule in the right part. So let's start, for example, with the tags, and let's dig in with the first tag, for example, the TR1 that we see in the top of our plan, the TR1, which represent the earthwork phase. And then we'll have the foundation, the BP1 tag for the concrete clearance. The foundation phase is divided into two parts, as you can see, from FD1 to FD8 in green, and the second phase is from FD9 to FD15 in the second phase. As I said before, we have the schedule. We can see we have the name of the phase, the volume, and the tag, the identifier of every element. Let's return to the 3D view with filters and review the information we added to each element. As we can see, we've assigned an ID to every element as well as a unique mark or tag. Each element in our geometry has two unique identifiers, one for the ID and the other of the mark or tag that we use on the plan. Let's move to the schedule and review the information we can extract from each element. In this example, we've generated a schedule with IDs using Dynamo. To summarize our situation, we have a 3D geometry with a view, and we've created a schedule that includes essential information such as the ID, tags, phases, and volume. This data can be translated into monetary values and used for the design estimations. Each element and phase in the project contains this information. Later, we'll demonstrate how to link the ID and geometry using Speckle. Additionally, we will link the tag in the schedule with the Google Sheets to further connect the geometry and the information. We've also created plans for each floor, allowing us to track every element in 2D using tags, following the traditional system of tracking elements on site. In essence, this approach brings the gap between the old method of tracking site elements and the BIM technology by using the unique IDs or identifiers for each element in the geometry. So I will talk again about the ID and how for this example we use Dynamo to get the ID of every element created inside of the element with a parameter, but we can use another way to get the ID using the die roots. Yes, we also have the schedule and the IDs integrated into the elements of our model. As I mentioned, we can generate these IDs using tools like die roots and SheetLink. Here, we'll export the data to Excel to showcase both the automatically created IDs from die root and the IDs that we generated using Dynamo. As you can see, the IDs are identical, so it doesn't matter how to obtain the information. The most important thing is having this information, as it allows us to link elements together in our next phases of these videos. Now, let's return to the 3D view and send the model to Speckle. As you can see, I already have a stream or a project set up, so I'll simply select the elements and send them to Speckle. Takes not a lot of time because the model is small. So here we have the model. After the elements are sent, we can view the same geometry in Speckle viewer. Let's try retrieving the phases, for example. We can search for the phase parameter, and then we have it. We have all the phases. We can color elements using this phase. So as you can see, everything is okay. So we can search also for the ID element, which is called element ID in Speckle, and color elements using this ID. And lastly, we can look for the tag that is mark on Revit and color elements according to this parameter as well. So we can see everything is working well, every information is there. In addition, we have the Google Sheet we exported from Revit. It contains information such as category, family and type, phases, ID, volume, cost per cube meter, and the cost for each element including 5% markup. All the information provided for the design team is really there, including the tags, and we can use these tags to track elements on our floor plan. So really we have all the information that has to be provided from the design team. Everything is there, so we can track everything and go to the next step. So now let's switch to the last part and the fun part, the question part. So I didn't get a lot of questions, so I have chosen 3 of them. So the first 2 questions were about how is the workflow doing now, and is it working, and what was the challenges. And the second question was referring to some information, like for example volume, and why I am duplicating the volume on this workflow. So for the first question, unfortunately, the workflow is not working because I left my last job. So this workflow was created in my last job. I used it in 2 or 3 projects, small projects. It worked pretty good, but the big obstacles or big problems I got is the managers that are not understanding the benefit of those things. So yeah, this is a big challenge, but I try to get the most not expensive, and we can say really cheapest or for free. For example, why I'm talking about Speckle a lot, because Speckle is an open source platform that is really going in a very, very interesting direction. So yeah, I try to use this software and platforms that are for free, open source, and get the same result or even sometimes better results than the big software that you have to pay a lot of money using them. So this is responding to the 2 first questions. And to the last question, why am I duplicating the volume? So as most of you know, that we have 2 types of information. We have the information that are provided from the design team, that is theoretical, and then we have the real quantities, the real cost, the real information on site, because on site everything changes and everything has another type of information. So that's why I'm duplicating, and I will explain this in my next video. So thanks for watching and see you next video. And I have to apologize because it took me a lot of time to prepare this video, and I'm sorry for my English if my English is not very strong. So thank you everybody, and see you in my next video.